Hi, and welcome to Data Analysis and Visualization, another lecture in our summer course on Applied IoT. So today we're going to just dive into this enormous field of data science, how to analyze data, how to visualize data, but on a very basic level. So this is an introductory course to Internet of Things, and data analysis and visualization is a very big, very large field. So we're not going to go too deep, but this is my heart and soul. I'm myself a data scientist, and in the field of Internet of Things, I am mostly working on the soft side. So with the what happens after you manage to connect all your devices together, you get your sensor readings, and at the large scale, what happens with this data, how to efficiently store it, retrieve it, analyze it, visualize it, and all of that. So this is very close to my heart, so I'll try my best to ignite your spark and inspire you to investigate this further, way beyond your project, and go on and study and experiment with this. So let's start. If we view the IoT system architecture, it can be your project, or in general, it looks very similar. You have some kind of devices. Each of them maybe is controlled by a microcontroller. Maybe you have some gateways. So this is what we've been working on up until now in this course. Let's assume that now we managed to send the data through some way. Maybe it's MQTT, maybe it's some other protocol. You are sending your streams of sensor data to your backend. Backend in this case, it can be a ready-made, no-code platform, like one of the ones we offer in the course, like UbiDots, Adafruit. So in this case, this will all be handled by the platform, so you don't need to implement anything. But the principle that is behind this IoT platforms is the same as if you would implement your own self-hosting solution in the course. It has some kind of database which is used to store data. It maybe has some kind of logic to both handle the incoming streams of data and the data retrieval. It often has an API, so programmatic access to the database. And you will see that this no-code platforms often still offer this for developers. Like, okay, here is how you extract your data through an API in your code. And even if you pick in this course to not focus so much on this development part of this solution, still do try to dive into the IoT platform that you have picked. How is it built? What kind of database are they using, if that information is available? For how long are they storing the data? Do I have just a few days, a month? If I'm to extract the data, is it everything that they provide, or is it some small subset? Do I get the raw data the same way I send it from the sensor, or is it only an average value in 5 minutes? So this is important both for your project, so you can explain this your implementation and what you visualize later, but even in general when you execute any type of IoT project in the future. Then from this, then we go like, okay, now we have some kind of data management layer. What do we do with it afterwards? This is where this week is going to revolve around all the tutorials, all the materials, and all the practical part. And your goal then is to somehow visually represent your data that is relevant in a way that is relevant to the problem that you're solving. So in general, data analysis, as I said, is a pretty big field, and often the process starts with some kind of exploratory analysis, right? So, okay, let's just try to clean the data, try to understand what we have, try to gather the historical data and see how it looks like. So basically answer the question about, okay, what has happened in a certain period of time. And here you can get help from some simple statistical analysis that you have probably even done in high school, if not in any of your higher education. Mean value, median, total sum, some missing values. Try to start the process with that, and then think, okay, what can be a good visualization that lets me to explore my data. Then in you can go as far as to so-called predictive analytics or prescribed analytics, answering the questions: what will happen in the future, and how can I act on what has happened? So the example here could be that if you're gathering some kind of the simple temperature and humidity data, that you set up the logic that at a certain values you get an alarm, maybe both in your visual interface and then somehow as an action, like something in the hardware gets a feedback and maybe some kind of light is blinking. And then even predictive as potentially, is it useful to have some kind of logic that with simple maybe machine learning or even just regression model will tell you, okay, what will the next value be? What will happen if this? Maybe you're connecting several weather parameters from your weather station, and you have previously gathered data that when it's raining, your solar panels don't produce so much sun, and when this value of the electricity price is at a certain level, you don't want to launch your dishwasher. I mean, if this is a home automation problem. So this will be the simplest case of predictive analytics. Often it's also relevant to look at why did things happen. So IoT systems often are used for diagnostic purposes. So both detecting anomalies and setting things against each other to see what caused what. It could be simple correlations, which you can only see through analysis, but sometimes data visualization through dashboards can also help with just overlaying. So in short, then, the data visualization and our goal here in both in this project and in general is to uncover patterns and relationships in the data that otherwise might just have been lost in the vast stream of things. This is a very good intuitive thing to do in any IoT project, and often already at the data storage level, the tools provide you with simple visualizations. So always look at your data. First step, is there something weird? Next step, what questions can I ask? And how far can I go with my visualizations? And in the IoT world, when people say data visualization, they often mean dashboard. So not just one graph that is static, but a whole set of graphs that are often interactive. So the user can hover over different time points and then see, okay, when I had this temperature, what was happening? For instance, in my home automation system at the same time. If it's a map of sensor locations, can I see and click on specific sensor in a specific region? If it's more of an application for the end user, then the dashboard might be incorporated in an app where a user can also take action. on like here on the an example, like it's find your keys. I wish I had that button. So in our projects, we're also aim at creating, for the very least, a simple dashboard that lets you solve your the problem that you're focusing on. And one of these examples is here, for instance, a dashboard that we created at the IoT lab for yrkeshögskola, for a college here in the area in Oskarshamn. They're interested in electricity consumption patterns throughout their buildings. So they install the smart meters, which feed the data on how they consume electricity. And we also incorporated electricity pricing API to visualize, okay, this is how much money you have spent today on this freezer or on running the elevator up and down. And this is now built in Grafana. So this is the TIG stack, Telegraph, Influx, Grafana, and the data is, for the plots is extracted using Flux. This is the query here. So this could be, this is for your inspiration of what is possible to do. Here we see like a overlaid line graph. And let's see here if I can go further. So your goals then, when you start designing your dashboard, picking plots, I want you to think about these 4 things. The goal of the dashboard is to simplify complex data, not the opposite, present simple data in a complex way. Often what we want from the IoT system is also real-time monitoring. And so you want the first impression to be, okay, what is happening right now? And in some way facilitate decision-making. Now that might be part of your project or not. Maybe there is no decision, like in this case, in the previous one, right? Okay, we're interested just to first explore how we consume electricity. Maybe we'll see, okay, yeah, obviously when the temperature is lower outside, our electrical heating kicks in, and this is increasing the price. There is no direct action from that. Like there is no button, okay, stop heating right now. Not yet anyway, but this is still designed to facilitate decision-making in a way that it lets me extract information that is needed to take a decision. So for instance, in this case, the moment they saw these graphs and played around a little bit with them, they were like, wow, our pump for the heating, it has this strange pattern, and this might mean that we need to replace it. So this becomes apparent when you see this information visually. And then the next maybe step, right, is a predictive insights. That is on the advanced part of data visualization, but it doesn't hurt to think about it already now when you're starting with your project. How can it be used for predictive insights? That will help you design what plots to choose and how to present the user with them. Then what is good to mention is the common data types in IoT. It is time series data, and usually that's right what we have been looking at here, right? Time series data, it just means that you have a lot of pretty small records that are time-stamped. There are also different categories of time series data. Often you just have a constant state, and very rarely you get some kind of change. That depends on what your sensor is measuring. In the case of IoT, it's often also the case if your system is monitoring something and only changes get reported. But in general, all time series data is similar then. And along with that, you often have also more tabular data, so numerical and categorical data that is connected somehow to these measurements. It could be in general like asset tracking, it could be status of the sensors, locations of the sensors. It's more of a categorical data. It could be useful sometimes to connect the time series measurement data with general inventory. So, for instance, if you're measuring at different locations in your home, or if it's some kind of production in industrial area, to have some information on each of the locations of your sensor. And that is often in some kind of tabular format, right? That we are more or less used to with like Excel and any type of data we're used to be represented as a table. And sometimes we we want to represent time series data also as a table. And if you have been studying software engineering or web programming, you might already be familiar with databases. If you're not, don't be scared. Again, in the course, you have the possibility to both go advanced and dive deep into this area, or do a low-code solution, and that's perfectly fine. But I still want you to understand the differences, what's happening on the back end of these systems, and how the time series storage is different from other types of storage. Then, of course, no one is stopping you from storing your sensor data in a regular SQL. You can store it in a text file, right? And it will probably work for your simple prototype solution. But if we look at the bigger picture, then there is a whole vast sea of just time series databases that are optimized for retrieval of this often very large amounts of data that coming from many different sensors. And the special thing about these databases is often that it is assumed that the data in the past doesn't change. Like, it is not possible to change this sensor reading from 3 months ago, or it's probably not relevant if you even would like to do that. So that's why they are built in a completely different way. So if you're used to relational databases, it might be difficult to to understand. This has been, I worked a lot with tabular data before coming to the world of IoT. And it's actually the first time I've seen a time series database. It was not related to IoT. It was for system monitoring. And I don't know what was the the first application of the, for instance, InfluxDB is one of those time series databases. But for system monitoring, it is also often used. So, for instance, like uptime of your servers, logs of different errors of your user behavior. That's also very similar data pattern to sensor data. And here we don't have tables. We don't have like references or IDs. Everything, you kind of have to throw that away and think differently. So you have buckets. Instead of you have a bucket that is we can say that's your database. And then the corresponding to relational thinking specifically in Influx to tables is measurement. So you think measurement, or you think sensors. Often data from each sensor is assigned to the same measurement. So if you have one sensor that reports temperature and humidity at the same time intervals, that probably will be one measurement in your bucket. And measurement is just a name, so it just looks as a tag. The data in Influx is built what you will see at least on the outside, and when you try to ingest data in it, is this line protocol. So each data reading is a line that is formed in a certain format. So here's like one of the examples. In this case, measurement would be the name of your measurement. Then you can have different values, and each value has a field name, which is called field, for instance, temperature, and then a value, which will be a number for your value. So if we have some kind of climate sensor, let's call it that, we have temperature and humidity, and you can also add tags, so additional information. So instead of, you recall this tabular data that I was talking about, instead of creating some kind of table that has sensor 1, location, column this, and so on, you will mark instead every reading from that sensor with a certain ID and a certain location. And that is made so you can easily then aggregate data by location or by sensor ID without compromising your performance on fast ingestion of data from the sensor. So this is basically it. And yes, of course, every measurement has your timestamp. So you can say that all of data storage in Influx is indexed by a timestamp. So it's extremely efficient on both insertion and ingestion and retrieval on timestamp and aggregating on all sorts of things. It happens like this. So Influx then is the part of this TIG stack on our roadmap, and it already has some built-in visualization features, so you can directly look at the very simple line graph for your measurement, but it also integrates seamlessly with Grafana. This is what I showed you a few slides before, and then you can build queries to Influx to retrieve all sorts of different combinations of your data to create a nice dashboard. Then, yes, I mentioned line charts, right? So this is probably will be the simplest and the easiest thing that you will create first. And as I said, if you go the Influx route already in your in the interface of Influx, you will be able to create a line chart pretty easily. So see and explore, that basically means that you have a timestamp on the x-axis and then the value on the y-axis. It doesn't get more simple than that, right? So this is the first chart that you probably should consider. Sometimes it's relevant with the bar chart, especially if you're aggregating the data on a certain time point or a category. So that is also something that we often expect to see, right? Another thing is this gauge charts. I'm not sure how it's pronounced, right? So this is very useful to, it's a bit like similar to your dashboard in a car or in any other vehicle, I suppose. How much gas do you have left, right? But it's also very relevant, like if you're measuring something, again, that you would like to have a visual alert on, temperature is getting too high or too low, CO2, like this level is getting too high, maybe it's a radon levels in your house are getting dangerously high. This is a chart that's also like add that to your dashboard. If you have installed many sensors, and this is obviously not in the whole world like here, but maybe you have a garden, right? And you have a bunch of sensors, or you want to visualize different sensors in your, even around your house. Consider a map with sensor locations and the possibility to click. Now, not all of the low-code platforms provided, and that might be slightly more advanced sort of visualization technique, but often both Grafana and UBDots, I think also, you can insert different modules in your in your dashboard to just visualize the map with locations. Maybe you won't be able to click on them, but it's very good to see the overview of your project. If you do have many sensors, where are they located? And that can be as simple as an image and as advanced and full integration with Google Maps with geographical location of your sensors. So that is also a very useful thing. Then, as I said, of course, there are tons of graphs. Just in Grafana, you can get lost in many ways to visualize your data, depending on what you would like to show, right? Then one challenge might be that you have just set up your prototype and maybe you collected data for like a few hours, right? And you can't even maybe see that much. But this would be the map I provide. There are sources in the slides if you would like to see where it's coming from, but it's very famous sort of mind map. Okay, what to choose. You might not have distributions. I mean, who knows? Sometimes scatter plots can be useful to visualize relationship between two variables, like for instance temperature and humidity, right? The simplest one together. So do explore that, and if you need any help, of course we will come up with ideas of what can be relevant to do. What I showed was this stacked area charts. To me, so this is similar to a line chart, but to me was I prefer that because it's easier to see what is higher and what is not. So very useful, I think. Then, as I said, the best practices, we can probably have another course on data visualization, and we are here just going to touch the surface. Here are the screenshots of the two books that are the Bible of every data scientist, and if you're going to continue in the field, I strongly suggest you have a look at them. This is Tofte and the Visual Display of Quantitative Information. I have it at home. It's a ginormous book. It's very old, so it was written for graphs that people sort of start like drawing on paper, but it is still amazingly relevant. And there is a whole science of UX research and how to present data in the best way. But for the sake of this project, remember a few things. Time access. This is your base, right? That's probably a lot of these platforms will do for you automatically, but make sure you don't skip values. Time periods, even if you don't have any values. Try to, but also don't fill them in with something that is completely irrelevant. Try to look at your simple line chart and figure out if there are any problems with it, right? With how you report the data. This often can be your diagnostic tool as well. If you do some kind of bar chart to have a comparison, to, I don't know, show which sensor reports the most, or I don't know, whatever it could be, right? Always sort your bars, yeah, so ascending or descending, so it's easier to see. That's often a setting in these platforms, doesn't always come automatically, and the same goes for pie charts if you want to to show like a slice and some kind of statistics on the data. Colors are also important, and there is quite a lot of settings in all of these platforms to adjust that. If you're implementing visualization on your own, which is also perfectly fine if you want to go that way, build your own website, use Plotly for interactive graphs in Python, or G3 in JavaScript. There are a lot of tools to pick a good color palette, and ready-made designs that are colorblind, people-friendly. And sometimes, if you have very simple graphs, consider skipping colors. Basically, if you only have two variables, maybe you don't need red, green, purple, and so on. Maybe you just need a grayscale. The simpler your data representation, the easier it is to interpret it. And that comes to the next point, data complexity. Remember, your goal is to make data that we have simpler, not the opposite. So don't add too much information in it, and always remember who your audience is. If you're building this project for yourself, only for the course, or if you know that a certain type of people will look at that. So, for instance, if for a more technical user, you want to go for in more detail. For the not so technical people, or if it's, for instance, for people with disabilities or elderly, you want to definitely check it with the VisCheck, and also don't just bare minimum of information on your dashboard. And yes, now to the roadmap. I hope this was helpful. Please go on to our next recording, where we go through different visualization platforms. And I thank you for today, and good luck with creating your wonderful IoT dashboards. Bye bye.